What if I told you that somewhere in the universe, a black hole is growing so fast that it's breaking the fundamental rules of physics? Not millions of years in the future, not in theory, but right now, and NASA has seen it. This black hole existed when the universe was still young, before galaxies had fully formed, yet it already weighed millions of times more than our sun, and was feeding at a speed scientists once believed was impossible. According to everything we thought we knew, this object should not exist. So how did it form? How did it grow so fast? And what does this discovery tell us about the early universe and the limits of physics itself? Tonight, we dive into one of the most shocking discoveries in modern astronomy. When astronomers analyze the universe, they expect surprises. But every once in a while, something appears that forces science to stop and rethink everything. This was one of those moments. Using NASA's Chandra X-ray Observatory, along with data from other powerful telescopes, astronomers detected a distant quasar, an intensely bright object powered by a supermassive black hole. At first glance, it seemed familiar. Quasars are rare, but not unheard of. But when scientists calculated how fast this black hole was growing, they realized something was terribly wrong, or incredibly right. This black hole wasn't just feeding. It was devouring matter at one of the fastest rates ever recorded. So fast, in fact, that it appeared to be growing beyond the Eddington limit, the so-called cosmic speed limit that should prevent black holes from growing too quickly. In simple terms, this black hole was cheating. What makes this discovery even more mind-bending is when this black hole existed, the light NASA detected began its journey. Over 12 billion years ago, that means we are seeing this object as it was when the universe was less than 1 billion years old. To put that into perspective, the universe was still forming its first galaxies. Stars were only beginning to organize. Heavy elements were rare. And yet, this black hole had already grown to monstrous proportions and was feeding like a cosmic beast unleashed. According to traditional models, there simply wasn't enough time for a black hole to grow this big, this fast. So how did it happen? To understand why this discovery is so shocking, we first need to understand what black holes are and how they grow. What exactly is a black hole? Despite their terrifying reputation, black holes aren't cosmic vacuum cleaners or holes punched through space. They are objects of extreme gravity. A black hole forms when a massive amount of matter is compressed into an incredibly small region of space. There are different types of black holes. Stellar black holes form when massive stars collapse, typically a few times the mass of our sun. Supermassive black holes, found at the centers of galaxies, millions to billions of times more massive than the sun, including the one at the center of our own Milky Way. The black hole NASA discovered belongs to this second category, but its growth history doesn't make sense. Black holes grow in two main ways. One, accretion, pulling in gas, dust, and stars. Two, mergers, colliding with other black holes. As matter falls in, it forms a spinning accretion disk. Friction heats this disk to millions of degrees, causing it to shine brilliantly in X-rays and light. Ironically, the brighter a black hole shines, the harder it should be to grow, because intense radiation pushes matter away. And that brings us to a crucial concept. Physicists believe black holes were limited by a balance. Gravity pulls matter inward. Radiation pressure pushes matter outward. At a certain point, these two forces should balance perfectly. This balance is called the Eddington limit. Cross it, and the black hole should choke on its own light, slowing its growth dramatically. For decades, this rule worked beautifully. Until now, the black hole NASA observed appears to be growing at multiple times this limit, which raises a terrifying question. If black holes can break this rule, what other cosmic limits might be illusions? If this black hole can grow faster than physics allows, what else in the universe might be hiding beyond our understanding? One of the biggest reasons this discovery is important is the age of the universe at the time this black hole existed. Astronomers estimate that the universe is about 13.8 billion years old. The black hole observed by NASA existed more than 12 billion years ago, meaning we are seeing it when the universe was less than 1 billion years old. This creates a serious scientific problem. Why? Because black holes need time to grow. Under normal conditions, a small black hole forms first. It slowly gains mass through accretion. Growth is limited by radiation pressure. even growing at the maximum allowed rate. Standard calculations show that there was not enough time for such a massive black hole to form so early. This mismatch between observed black hole mass, available cosmic time, is known as the young universe black hole problem. NASA's observation adds strong evidence that our current growth models are incomplete. How fast is this black hole actually growing? To understand the scale of this discovery, scientists measured how much material the black hole is absorbing. Based on X-ray brightness and radiation output, astronomers estimate that this black hole is consuming hundreds to thousands of solar masses per year. For comparison, the supermassive black hole at the center of the Milky Way grows extremely slowly today. It absorbs less than one solar mass over very long periods. This means the newly observed black hole was growing millions of times faster than typical black holes we see nearby. Such rapid growth was previously thought to be extremely rare or physically unstable. How NASA detects and measures black holes. Black holes themselves emit no light. So how can NASA study them? Scientists rely on indirect evidence. Key tools used: X-ray telescopes like Chandra, optical and infrared observations, spectral analysis of light. When gas falls into a black hole, it heats up to millions of degrees, emits strong X-rays, produces a bright central region called a quasar. By measuring brightness, energy output, motion of surrounding gas, scientists can estimate black hole mass, accretion rate, growth speed. This method is well tested and widely accepted across astrophysics. What is a quasar? A quasar is not a star or a galaxy. It is the active center of a galaxy, powered by a rapidly growing supermassive black hole. Quasars are among the brightest objects in the universe, visible across billions of light years. Most common in the early universe, the black hole NASA studied is classified as a quasar-powered system, which explains its extreme brightness and growth rate. Importantly, quasars do not last forever. Once fuel runs out, they fade. This suggests the observed black hole is being seen during a brief but intense growth phase. Most black hole models assumed gradual growth, stable accretion, strong radiation limits. NASA's observation challenges all three assumptions. It suggests that under early universe conditions, gas density may have been much higher. Radiation may escape unevenly. Accretion could occur in bursts. This allows black holes to grow faster than expected, without immediately stopping themselves. Astronomers are now testing several explanations. Keycap 1 Super Eddington accretion. Black holes may temporarily exceed growth limits if radiation escapes in narrow directions. Keycap 2 Dense gas environments. Early galaxies contained large amounts of cold gas, feeding black holes continuously. Keycap 3 Direct collapse black holes. Some black holes may have formed already massive, skipping the slow early growth stage. None of these explanations are confirmed yet, but all are actively studied. This discovery strengthens a major question in cosmology. Did galaxies form around black holes? Or did black holes grow inside galaxies later? Evidence increasingly suggests black holes may have formed very early. Galaxies may have developed around them. If true, this changes how we understand galaxy evolution, star formation, large-scale cosmic structure. NASA's discovery does not break physics, but it shows that our models are incomplete. Science advances by observing unexpected results, updating theories, testing new explanations. This black hole provides a real-world laboratory for testing gravity, radiation, and extreme environments. Can black holes still grow this fast today? In the modern universe, gas is less dense. Galaxies are more stable. Extreme growth is rare. However, short bursts of rapid growth can still occur during galaxy mergers, gas inflows, but nothing comparable to the early universe conditions. NASA's James Webb Space Telescope is now searching for even earlier quasars, smaller seed black holes, first-generation galaxies. Future discoveries may show that fast-growing black holes were more common than previously believed. NASA's discovery of a rapidly growing black hole shows that the early universe was more extreme than expected. Black hole growth can exceed traditional limits. Our understanding of cosmic evolution is still developing. This does not weaken science. It strengthens it. Every unexpected discovery brings us closer to understanding how the universe truly formed. NASA's discovery of a rapidly growing black hole shows that the early universe was far more extreme than previously believed. Under those conditions, black holes could grow much faster than today, helping explain how supermassive black holes formed so early in cosmic history. This finding does not overturn physics, but it improves our models and deepens our understanding of how the universe evolved. If you found this explanation helpful, consider subscribing for more evidence-based space documentaries. Leave a comment if you'd like us to explore another recent NASA discovery, and share this video with anyone interested in how our universe really works.